All right, so we continue with the marginal rate of substitution. Now, when you have the indifference curve, the slope of the indifference curve is what we call the marginal rate of substitution. It measures the rate at which a consumer is willing to sacrifice one commodity for another. Okay, to sacrifice one commodity for the other. Now, if you take a normal indifference curve that slopes downwards and bows inside like this, there is something called the diminishing marginal rate of substitution, which means that as you move down the indifference curve from top right to uh, from top left to the bottom right, the marginal rate of substitution decreases. What this means is that if you're on top, if you are at point A, for example, if you look at this, the marginal rate of substitution here is 6, which means this individual is willing to sacrifice more units of what, of mangoes, the quantity on the vertical axis, for just an extra unit of the quantity on the horizontal, which is fish in this case. So 6 means that he's willing to sacrifice 6 units of mangoes just for an extra unit of fish. But as you move down up to point B, you realize that the marginal rate of substitution has decreased from 6 to 2. So what this means is that at point B, this individual is only willing to sacrifice 2 units of mangoes for an extra unit of fish. And the reason is that if you are at point A, this individual is consuming so much of mangoes. So just sacrificing some for fish doesn't really affect this individual. He doesn't really care much about that. But by the time you get to point B, now you are rather consuming less of mangoes and then relatively more of fish. So he wouldn't be willing to sacrifice more units of mangoes just for an extra unit of fish, a commodity that he is actually consuming much of. So as you move down the indifference curve, this normal indifference curve, the marginal rate of substitution decreases. Okay, it decreases. But let's look at an extreme case, a case for perfect substitutes, where when the two commodities in question are substitutes, the marginal rate of substitution doesn't decrease. Okay, it has a constant marginal rate of substitution. And the reason is that the indifference curve is a straight line. Okay, the indifference curve is a straight line. So if you look at this example here, this is for nickels and then this is for dimes. What this means is that this individual is always willing to sacrifice 2 units of nickels just for an extra unit of dime. So it doesn't really matter if the person is here, the person is here, or the person is there. The marginal rate of substitution is constant throughout, unlike the normal indifference curve that bows inside. Okay, and so this is the case for perfect substitution. And then for perfect complements too, they have an L-shaped indifference curve. Okay, the indifference curve is a right angle. Now if you look at this, let's take the first indifference curve, I1. Okay, for right shoes is the two groups are right shoes and then left shoes. If you look at this with this green point here, what it means is that this individual is equally better off when he consumes 5 units of left shoes and then 5 units of right shoes. And then if you come to this point, this red point here too, whatever satisfaction that he gets is just the same as consuming 7 units of left shoes and then 5 units of right shoes. Okay, so for this is also another shape that the indifference curve can take. So this doesn't take the normal form or the normal shape of the indifference curve as we know it. Okay, so this is the case for perfect complement. There'll be cases where in exams you'll be asked to draw the indifference curve, so maybe perfect substitutes or perfect complement. So you know that for perfect substitutes, the indifference curve is just a straight line, and then for perfect complements too, it has an L shape. Okay, it has an L shape. So those are the two extreme cases. What about less extreme cases? Okay, where the goals are substitutes, but they are not perfect substitutes. Okay, when it happens like that, they take this shape. Their indifference curve bows inside, but it's not as much as the case of goals that has complements. They are not perfect complements though, but there's some complementarity between the two goods. For them, they bow inside more than the indifference curve bow inside more than the case of the substitute. If you know, for the substitutes, for the perfect ones, the lines are just straight lines. The indifference curves are just straight lines. So, but for the complements, you see that as they keep on bowing inside, by the time they get to perfect complements, then they will become the L-shaped indifference curve. And then for the substitutes too, as they are becoming more perfect, as the two goods are becoming more perfect substitutes, then the boundness will be disappearing. So it tends to become a perfect line. Okay, it tends to become a perfect line. So these are for less extreme cases. Okay, less extreme cases. Now let's look at the optimization of the consumer. Now, when we're talking about the optimization of the consumer, we are talking about the consumer choosing a particular bundle that will maximize his satisfaction or that will maximize his utility. So which bundle at all should this individual choose? We have seen the budget line. It gives the bundles of goods and services that the individual can afford, given the price of the goods and then his income. And then we've seen that the indifference curve records or gives the bundle of goods or combinations of the two goods that will give the individual the same level of satisfaction. Okay, so given the preferences represented by the indifference curves and then the feasibility of the combinations given by the budget line, which actual combination should this individual go for? If you look at this indifference space, we have a budget line. Okay, this is a budget line. We have three indifference curves here. Now we have point B, point A, point D, and then point C. Now, if you compare point B and A, the individual prefer point B to point A because point B is on a higher indifference curve. But then you also prefer point A to point C and D because A is on a higher indifference curve than the point C and then the point D. Now, the individual will choose an optimal bundle where the indifference curve is tangential to the budget line, where you see that we have multiple bundles, multiple combinations of the two goods. Okay, so the person will go in for the point where the budget line touches the highest possible indifference curve. Okay, you prefer B, but you can see B is not affordable. It's outside your budget constraint, so you wouldn't go for that. And then for A is on the lower indifference curve, which means that for C is on the lower indifference curve, which means that if you choose C, you are getting a lower level of satisfaction than if you choose A. So at point A, this point A is the optimal bundle. This is the bundle that when this individual consumes will get the highest level of satisfaction. Okay, so why are we saying this is the optimal bundle? Because one, it's on the budget line, which means that this individual can afford it. We can see that D is also on the budget line. So why are we not going for D? The reason why we are not going for D, but we are going for A, is that A is on a higher indifference curve. Okay, the indifference curve that A lies on is higher than what D lies on. So the optimal bundle that a consumer will go for is the point where graphically the indifference curve is tangential to the budget line. Okay, but intuitively, we get the optimal bundle when the slope of the budget line is the same as the slope of the indifference curve. In other words, the rate at which the individual is willing to sacrifice one good for the other, as represented by the slope of the indifference curve, is exactly equal to the rate at which is actually able to sacrifice one good for the other, which is represented by the slope of the budget line. Okay, the slope of the budget line. So as I was saying, at the optimal bundle, the slope of the indifference curve and the budget line are the same. The slope of the indifference curve is the marginal rate of substitution, and then the slope of the budget line is the price ratios, the price of the good on the horizontal divided by the price of the good on the vertical. So here is price of fish divided by price of mangoes. Okay, so the marginal rate of substitution is measuring the value of fish in terms of mangoes, and then the slope of the budget line is also talking about the price of fish in terms of what? Mangoes. So when these valuation of fish in terms of mangoes are the same, then that is where the consumer actually optimizes its consumption. So if you consume at point A, where the budget line is exactly tangential to the indifference curve, there you are able to maximize your overall satisfaction. Okay. Now, given this optimization condition, what happens if there's an increase in income? Okay, what is going to happen to the optimal bundle when income increases? We have seen that with your budget line, when income increases, holding the prices of the two goods constant, the budget line will shift to the right, or it shifts outwards. So initially it was point E, but then because of the increase in income, the budget line will shift outwards, which means that this individual can move on to a higher indifference curve now. So that is going to be at point B. All right, so as the consumer's income increases, the budget line will shift outwards, and because of that, he's able to move on to a higher indifference curve. So he will move from point A to point B. So if you look at this, you can see that there is an increase in consumption of both goods. Initially, let me draw this. Initially, this was the quantity of mangoes consumed at the bundle A, the optimal bundle A. But now, because of the increase in income, you can see that the quantity of fish consumed has increased, and then that of mangoes has also increased. So this one is the case where the consumer sees the two goods as normal goods. For normal goods, we tend to consume more as income increases. So we moving from point A to point B means we are consuming more of both goods. But it's not always like that. It's possible that a good can be an inferior good. Okay, so these are the definitions of normal and then inferior good, something that we already know. When there's an increase in income, and then there's an increase in the demand for a particular good, then we call that good a normal good. But then for inferior goods, when your income increases, you tend to demand less. Okay, so for normal goods, there's a positive relationship between income and quantity demanded, and then for an inferior good, for a normal good, there's a positive relationship between the income and the quantity demanded. But for inferior goods, there's a negative relationship. When your income increases, you tend to buy less. So now let's look at what happens to the optimal bundle, the optimal combination of mangoes and fish, if mango is an inferior good and fish is a normal good. Okay, so we are initially this diagram that we looked at, both mango and fish were all normal goods. What if now it's only fish that's a normal good and the mango is an inferior good? We want to use the same diagram to show how the optimal bundle for fish and mangoes will be affected after an increase in income. Okay, so let's look at this. Now, mangoes are inferior goods. Let's not forget about that. It's only fish that's a normal good. So initially, this was point A, the optimal bundle A. Okay, the optimal bundle was at A, and we're consuming this quantity. We're consuming this quantity of mangoes and then this of fish. Now, after the increase in income, this is where we are. The optimal bundle is at point B. Now, I'm sure you can see that there's an increase in the quantity of fish that we consume, but then there is a decrease in the quantity of mango. So here, mango is an inferior good because as income increase, there's a reduction in the quantity, and then fish is a normal good because with an increase in income, there's an increase in the quantity produced. We could also draw this for the case where fish is rather the inferior good and then mango is a normal good. If that's the case, the new indifference curve will come somewhere here. Okay, sorry. So if this is the case, now this will be oh no. This is going to be the quantity of fish, and that will show a reduction from the previous one. But then this is going to be the quantity of mangoes that will show an increase from the previous one. So depending on the type of good in question, that should give you an indication of where the new indifference curve will go to. Okay, so this is the effect of a change in income. What about a change in price? When price changes, how does it affect the optimal bundle? Now, let's assume initially the price of fish is 4, okay, And then with that, this is the initial indifference curve with the initial budget line with the indifference curve. So this was the initial optimal bundle with fish 150 units and mangoes 600 units. Now, when the price of fish falls, the budget line will rotate outwards. So this red line is the new budget line. Okay, whenever price falls, holding the price of mango constant and then income constant, but then there's a fall in the price of fish, the budget line will rotate outwards like this. Okay, so we get our new indifference curve here. So this is going to be the new budget, the new optimum point. So at this point, the individual is now consuming 300 units of fish. You see that there's an increase in the quantity demanded of fish, but then there's a decrease in the quantity demanded of mangoes. So it falls from 600 to 500. So after the fall in price, the optimal bundle will move from 150, 600 to 300, 500. Okay, to 300, 500. So this is the effect of a price change. Okay. Now, the change in quantity demanded for fish from 150 to 300 units is called the total effect after the change in price or the fall in price. But this total effect can be divided or decomposed into two effects. Okay, into two effects. What we see, for example, if there is a change in price in any commodity in the real world, what happens to the quantity demanded that we see, that we realize in the market, we actually realize in the market is the total effect. But then within this total effect is what we call the substitution effect and then the income effect. So let's try and decompose the total effect into substitution and then income effect. Now, when you take income effect, okay, after a change in price, there's a change in purchasing power. Purchasing power talks about the quantity of goods and services that your income can buy. Before that, let me show you something. Let me give you the difference between nominal income and real income. Okay, nominal income. Let's take this as nominal income. Let's take this as real income. Okay. Now, assuming you have 20 Ghana cedis, okay, the 20 Ghana cedis, which is the face value of the money that you have, is what we call the nominal income. Okay, it's just the face value. But your real income talks about the quantity of goods and services that your nominal income can buy. So that is the purchasing power. So that one depends on the price level. Assuming the commodity that you want to buy is 10 Ghana cedis. Okay, 10 Ghana cedis. You are spending all your 20 cedis on 10 Ghana cedi worth of good. It means that you can only buy 2. So even though your nominal income is 20, given a price level of 10, your real income is only 2. That is the quantity of the commodity that you can buy. So what happens if there's a fall in price? Assuming price falls, okay, price has fallen to, let's say, 5 Ghana cedis. Now, your nominal income is still the same. It's still 20 cedis. But if you go to your real income, because now price is 5, the real income is nominal income divided by price. Okay, so now your nominal income is going to be 20 divided by 4, which is going to be what? Divided by 5, which is going to be 4. So if your income is 20, but now your price is 5, then you can buy 4 units. You see that there's an increase in your real income. So there's an increase in purchasing power. That is what the income effect measures. Whenever price falls, there's an increase in your purchasing power. In other words, your real income increases. But then if there's an increase in price, assuming price should rather increase, okay, assuming price should rather increase to, let's say, 20. If the price is now 20, what is going to be real income? Real income will be 1. You see that there's a reduction in real income. Okay, so when price increases 2, there's a reduction in purchasing power. So let's stick to this example. With this example, there was a fall in price of fish from I think $1 to $4. From $4 to I think one or two. So now because of the fall in the price of fish, there is an increase in the purchasing power of this individual. That is the income effect. So given that mangoes and fish are all normal goods, because of the increase in purchasing power, you buy more of both goods. Okay, you buy more of both goods. That is income effect. But then for the substitution effect, you are buying 2 goods. You are buying mangoes and then you are buying fish. Okay. Now, if there's a reduction in the price of fish, then in your eyes, now mango is relatively expensive. Fish has become relatively what? Cheaper. So you tend to buy more fish and then you buy less what? Less mango. That is the substitution effect. So if you look at this, when price falls, the income effect is causing you to buy more fish. The substitution effect is also causing you to buy more fish, which means that you buy more fish. Whenever there's a fall in price of a normal good, you buy more fish. But if you take mango, after the change in price of fish, the income effect is causing the individual to buy more mangoes because of the income effect. But then the substitution effect is causing him to buy less mangoes, which means that the total effect on mangoes will be ambiguous. We wouldn't know. It will depend on the magnitude of the two effects. If income effect is more than substitution effect, we'll buy more. Okay, we are going to what? Buy more. But then if the substitution effect is rather more than the income effect, then we are going to buy less. So as for the effect of the change in price of fish or mangoes, it's ambiguous. We wouldn't know. But for fish, whenever there's a fall in price, the income effect will cause him to buy more. The substitution effect is also cause him to buy more. So we are going to buy more of fish. Okay. All right. Let's look at how we show this on a diagram. Okay. This is our initial budget line with the initial indifference curve. Okay. So point A was the optimal bundle. So we're consuming this quantity of mango and this quantity of fish. Now there's a fall in price, so the budget line rotates outwards. It becomes the red one with this as our indifference curve. So this is the second optimal bundle. Now, if you want to get the substitution effect, okay, for the substitution effect, you draw a new budget line, okay, the dotted budget line that you see here, which is tangential to the old indifference curve but parallel to the new budget line. So draw a dotted line that is tangential to the old indifference curve. So being tangential to the old indifference curve means that you are still on the old indifference curve. That is the substitution effect. When price changes, you still stay on the old indifference curve. You are still on the same level of utility, but then you are now buying more after the fall in price of fish. You are rather buying more of fish. Okay, you are buying more of what? Fish. So now, initially we are buying this quantity of fish, but the substitution effect is from A to B, so we are buying more of fish, and then we buy less of what? Less of mango. So we move from this point up to this point. This is the substitution effect. So the dotted budget line should be tangential to the old one, but parallel to the new, to the old indifference curve, but parallel to the new budget line. Then from B to C is the income effect. You see that the income effect is causing the individual to still buy more fish. So from here to here. And then even for mangoes too, we are buying more from here to here. Okay, so from A to B is the substitution effect. From B to C is the income effect. So A to B, which is the substitution effect, is causing the individual to buy more fish and then less mangoes. But from B to C, which is the income effect, is causing the individual to buy more of both goods, both fish and then mangoes. Okay, so this is how we decompose total effect into substitution and then income effect. All right, so let's look at this question. It says that do you think that substitution effect will be bigger for substitutes or for complements? So we'll use two cases, one case for complements and then one for substitutes. We'll draw the indifference curves and then we'll see the substitution effect, which one is going to be bigger. So the first one, we have to draw an indifference curve for Coke and Pepsi. These are perfect substitutes. And on a separate graph to draw one for hot dogs and then hot dog buns. So these are complements. Okay, then we have to show the effect of a relative price, keeping the consumer on the same indifference curve. So let's see how those two happen. This is for Pepsi and Coke. These two goods are substitutes. So assuming there is a fall in the price of Coke, then a lot of people will stop buying Pepsi and then go and buy Coke. So don't you think that the substitution effect there is going to be very wide? Initially we're here. Okay, but after the change in price, after a fall in price, this is where the dotted budget line will be. So this is going to be the new optimal bundle. And look at the distance, because the two goods are substitutes, they are perfect substitutes. Assuming you are buying Coke and Pepsi. And then each price, the price for each good was say 10 cedis per bottle. You were buying 10 of both. Now the price of Coke has reduced to say 5 cedis. Even though you still want to buy Pepsi, it's very possible that you buy, let's say, 19 units of Coke, and then you just buy one of Pepsi. You are just buying it just for buying sake, but because you are perfect substitutes, you would like to buy more of the good that is now relatively cheaper. So it makes the substitution effect very wide. But if you come to two goods that are complements, they are consumed together to attain a certain level of satisfaction. So if there's a fall in the price of one, you are buying more of that. Okay. But just know that as you are buying more of that, you have to buy more of the other good as well. Okay, you have to buy more. So because now B is relatively cheaper, even if you don't want to buy more of the other good after a fall in price of the first good, you then have to reduce the quantity of even the the good whose price has fallen. You have to you cannot buy much of that, because if you buy more of that, you have to buy some of the other one to buy. Now in your eyes, you see the one whose price has fallen to be more cheaper, so you want to buy more. But just know they are complements. If you buy more of that, you have to buy more of the other, so it will prevent you from buy more. That's why the substitution effect is very small here. Okay, you see it's very small there, but that is not the case for substitution. All right, let's see how we derive the normal demand curve from this optimal decision by the individual. Okay. Now let's assume the price of fish was initially $4. So this is the indifference curve, and then the budget line, and then this is the demand curve. We know that for demand curves, it gives the relationship between price and quantity demanded. So when price of fish was 4, the quantity demanded was 150. So we get that from here. Initially, this was the budget line. This was the indifference curve. So the optimal bundle was at point A when price was 4. So the quantity demanded was 150. Okay, 150. So it was 4 and then 150 for price and quantity respectively. Now price falls to 2. The price of fish falls to 2. So the optimal bundle now shifts to point B, which is what 350. So when price is 2, the quantity demanded for fish was what 350. It was 350. So what is happening here? When price was 4, we're demanding 150. When price fell, we demanded 350. So when we connect these two dots, we get our normal demand curve. Okay, we get our normal demand curve. So this is how we derive the demand curve from the budget line and then the indifference curve. If price should fall again, okay, if price falls again, the budget line will rotate again. It will rotate again like this. Okay, it will rotate again like this, and then the indifference curve will probably come here. Sorry, I'm not even using a mouse, I'm using my hand, that's why. So assuming price falls to 1, so now price is 1 here. This can go to, let's say, 450. Okay, 450. So when price is 1, maybe you will buy like 450 units here. So 450 is here. So this is going to be the new dot here. Okay, the new dot here. So you just extend this. Okay, so that is what happens whenever price changes. So through this, we're able to get our normal demand curve. Okay. Let's look at application of consumer theory. The first one is for giving goods. Now, the question is that do all goods obey the law of demand? We all know the law of demand. Okay, when price increases, we are expected to buy less, and then when price falls, we are expected to buy more. But is it always the case? Okay, is it always the case? Let's look at this example. Suppose we have two goods, potatoes and meat. We are taking potatoes to be inferior goods. Okay. Now, assuming the price of potatoes rise. Now, assuming that the price rises, if it goes up, what is going to happen to substitution effect? We'll buy less of potatoes, right? Substitution effect. Price of potato has increased, so we'll buy less of it. Okay. So that we'll go and buy more of meat. So we'll buy less of potatoes. What about income effect? The good is an inferior good. When price rises, there's a fall in real income. So a fall in the purchasing power. Whenever there's a fall in real income, we rather buy more inferior goods. So the income effect will mean that you buy more of what? Of potatoes. Now let's look at this. What if the income effect, okay, what if the income effect is greater than the substitution effect? When income effect is greater than substitution effect, it means that we'll buy more of what? More of potatoes. Income effect means we buy more. Substitution effect means we buy less. So if the substitution effect is more than the income effect, then it means that after the rise in price, we'll buy less, and that will obey the law of demand. But what if the income effect, which is causing the individual to buy more of potatoes, is rather more than the substitution effect, which is causing the individual to buy less after the rise in price? So now, whenever income effect is greater than the substitution effect, when price increases, quantity demanded will also increase, which will violate the law of demand. And this is the case of a special form of inferior goods called gifting goods. For gifting goods, we rather buy more when prices increase. Okay, we rather buy more when prices increase. So this type of good violates the law of demand. Let's look at the graphical representation. Now, this is the initial budget line. This blue line here. Okay, and then the initial indifference curve, this, and then the initial optimal bundle was C. Now let's check potatoes. This was the quantity of potatoes. Now, if there's an increase in price, the budget line will rotate inwards. So we come to this red line inwards. But look at where the new indifference curve is, and the optimal bundle is at point E, which means we are buying more potatoes after an increase in price, but the law expected us to buy less. So you see that it is violating the law of demand. After the increase in price, we are rather buying more of potatoes. So for gifting goods, they do not obey the law of demand because the income effect is greater than the substitution effect. So that is one application of consumer theory. The other one is to the labor market, how we apply consumer theory to the labor market. So wages and the labor supply, how labor supply responds to changes in wage. Now, under this theory, under the labor market, wages and labor supply, the budget constraint that the individual faces here shows a trade-off between consumption and leisure. Here we take leisure as any non-work activity, anything that you do that do not earn you income. Okay, and then for consumption, we are talking about the quantity of goods and services that you can use your wage that you earn after working to buy, okay, and then to consume. So if you're able to buy quantities out of the income that you earn, that is consumption. So you working for more hours just to get money to engage in consumption means that you have less time for leisure. And if you want to have more hours for leisure too, it means that you are sacrificing the consumption, the goods and services that you could have bought. Okay, so this is the budget constraint, and the budget constraint depends on the time, the number of hours that you have in a day. Okay, and you are just know that you are dividing this number of hours between leisure and then working. Okay, between leisure hours and then working hours. Now, if you want to know the cost of leisure, the price of leisure for each hour that you take to enjoy leisure, what is the cost of it? Okay, the cost is the amount of consumption that you have to sacrifice. Okay, you see that when you take 1 hour for leisure, you are sacrificing the hourly wage for that hour. So just assuming that for each hour that you work, you earn a wage of 10 cedis. If you take 1 hour leisure, you have sacrificed this 10 Ghana cedis. But you could have used this 10 Ghana cedis to buy goods and services so that you increase your consumption. Okay, so the price of enjoying leisure is the wage that you sacrifice. So that is the budget constraint. And then for the indifference curve is giving us the bundles of consumption and leisure that will give the individual the same level of utility or satisfaction. So whether you go for 10 hours of leisure, 14 hours of work, or 8 hours of leisure, and then probably 16 hours of work, you get the same level of satisfaction. So that is what the indifference curve also pictures. Now let's look at the optimal bundle. Okay, the optimal bundle. Now this is the budget constraint, and then this is the indifference curve. Here the marginal rate of substitution for the indifference curve is the wage, is the wage rate. Okay, that's the trade-off between leisure and then consumption is measured by the wage rate. So now at this optimal, this is the optimal bundle. Okay, please, what you have to know is that in this analysis, when you are moving from right to left like this, you are increasing the number of hours that you take for work, and then if you are moving from left to right, you are increasing the number of hours that you take for leisure. Okay, so given these indifference curves, this is going to be the optimal bundle. So at this point, you get the optimal hours for leisure and then optimal hours for work, measured by the consumption. Okay, measured by the consumption. Now we want to know what happens to labor supply. That's the number of hours we offer for work whenever there's a change in the wage rate. Okay, so assuming there's an increase in the wage rate, what actually happens to labor supply? Here too, we have two effects. Okay, the effect that we see on labor supply is the total effect, but the total effect can be decomposed into substitution effect and then the income effect. So assuming there's an increase in the wage, let's look at the substitution effect. Now, you are thinking of consuming or, having time for leisure. And we are saying that the cost of leisure is the hourly wage. So if there's an increase in wage, then it means that now leisure has become more expensive. Okay, for each hour that you sacrifice for that you try to use to enjoy leisure, you are sacrificing so much wage that you could have used to buy goods and services. So the substitution effect will cause the individual to work more, go in for more hours of work, because now leisure has become relatively expensive. So whenever there's an increase in wage, the substitution effect will cause this individual to go in for more hours of work. But what about the income effect? Now, if we assume consumption and leisure to be normal goods, when the wage rate increases, there's an increase in this individual's income. So he can buy more of both. So, but just know that there's a trade-off between hours of work and then leisure. The person is now getting more money. He would love to go in for more leisure. So going in for more leisure means that you are going in for less hours of work. And even there are some people who have a certain level of income target. So if you increase the wage and it gets to that point, they don't have to work more. Maybe they just wanted the wage rate of 15. Now you've increased it up to 15, and now it's even past 15. It's up to 20. They'll just reduce the number of hours that they work. Why? Maybe they just want to get time to enjoy whatever money that they've gotten from working. So the income effect will cause the individual to go in for more leisure. Okay, and as you are going in for more leisure, you reduce the quantity of hours that you offer for work. So the income effect is causing the individual to work for less number of hours, but the substitution effect is causing the individual to work for more units of hours, for more hours for offer more hours for work. Okay. So now let's look at this. Let's look at the case where the substitution effect of a wage change for this individual is greater than the income effect. So we are here. This point here is the initial optimum point. Okay, so we're here. This was the units of labor, hours of labor that we supply for work, and then after the increase in wage, the budget line will rotate outwards. So we come to the red line here. This is for consumption. It's measuring the hours of work. So we see that there's an increase in consumption. So if you come to the labor supply curve too, there's an increase in the number of hours offered for work. The labor supply curve is drawn with wage on the vertical as against the hours of work on the horizontal. So initially wage was here, and this was the quantity we offered for sale or for work, and then now wage has increased. We are offering more hours for work. So the labor supply curve is an upward sloping curve. Okay, it's an upward. So which is giving an indication that as they increase wage, we tend to work for more hours. But it's not always like that. It's not always the case that when they increase wage, we work for more hours. Okay. What if the income effect is rather more than the substitution effect? If the income effect is more, then after now this was the initial optimum point. Then the income increase. This is the new budget line, new difference. But look at where the optimum point is now. It means there's a reduction in the hours of work. In other words, there's an increase in the hours of leisure. So then the supply curve becomes downward sloping, which means that there's going to be an inverse relationship between wage and then the hours of work. Okay, the hours of work. So this is the reason why we have something called the backward bending labor supply curve. The labor supply curve will initially be like this, but after some time, if you keep on increasing the wage rate, you will realize that the labor supply curve will become like this. It will turn or it will move backwards. Okay, so you increase wage and rather the hours of work wouldn't increase, but it will rather decrease, and then it will take the shape of the second one that we saw. Okay, the second one that we saw. So that is the other application. Okay, but the question is that does it really happen like that, where the real wage increases and then we see labor supply falling? Can the income effects rather be as strong as that? And these are some evidence that over the last 100 years, because of technological progress, we see labor demand that there's some increase in labor demand because people are creating more jobs, producing more commodities and all that. And because of the increase in labor demand, there's supposed to be an increase in real wage just to attract people to come and work. And now, as a result, the work week rather decreased from 6 days to 5. Initially, the work days were from Mondays to Saturdays, but now it has become Monday to Friday, which means that there's a reduction in the hours of work. This one, the work week has fallen, which means that the income effect there is quite strong. Okay, it's quite strong. And then another case is where someone wins a lottery or a bet. Okay, when you do that, it's very possible that the person wouldn't even work at all or try to reduce the number of hours that he works. Here, there's no substitution effect at all because there's no change in the wage. But then because the person has become more wealthier, the income of this person has increased. So he tends to stop working or reduce the hours of work, which means that this is the work of the income effect. Here, the income effect is more than the zero substitution effect, and it's causing the person to work less. So yes, it is possible. It can happen in the real world. Okay. The last application that we'll be looking at is the interest rate and savings. Interest rate and savings. This, when you get to level 3 and the first semester macro, you do this again. Okay. Now we are assuming this individual lives for 2 periods. Period 1 is where the person is young and he's energetic, he can work. The youthful years of the person, he works and then he earns $100,000. Okay, so now the consumption in the first period, the consumption for this individual when he's young is going to be the total amount of income he earns, which is 100,000, minus the amount that he saves. You see that when you are young, you have to save so that when you retire, you can use your savings. So the consumption level in the first period is the total income minus the amount that he saves. Now, when it gets to period 2, this is the person's old age and he's retired. He cannot work, so he's not earning any income at all. So the consumption in the second period is going to be the savings that he made from period 1 plus the interest that you earn on their savings. You can see that when you save, you earn something on it. And whatever interest that you earn depends on the interest rate. So the consumption level in the first period is going to be your total income earned minus the amount saved. And then the second period, when you are no more working, your consumption, there's going to be the savings that you made when you were young plus the interest. that you get on that savings. Now, when you take the interest rate, okay, it determines the price of current consumption in terms of the old age consumption. In other words, it's talking about the interest rate is giving you the price of consumption in period 1 in terms of consumption in period 2. Now, when you save, you earn interest on it, okay? So when the interest rate is very high, it means that you don't have to consume much now. Save more so that you can earn more interest on it when you consume. So we are saying that the interest rate is the cost of current consumption, the consumption in period 1, which means the higher the interest rate, the more expensive it is to consume in the first period. So you rather increase your savings and reduce your consumption, okay, and reduce your consumption. So let's look at something. So if you take the indifference curve for this individual, the marginal rate of substitution, that's the trade-off that he makes between current consumption and future consumption, is the interest rate. It's measured by the interest rate. This budget constraint is drawn for 10% interest rate. So we are assuming that this individual earns 10% on whatever amount that he saves in period 1. Remember, he earned 100,000 in the first period. So if he wants to consume everything, I'm showing you how to draw the budget line. If he was earning 100,000 in period 1 when he was young, so if he wants to consume all the 100,000, this is what it will be without consuming anything at all in the period 2. So this is what it will be. Okay, so this is the first extreme case. And then the second one, assuming he doesn't consume anything at all in the first period, it means he will save everything. When you save $100,000, you earn 10% interest on it, and that will be $10,000. So if you want to consume all your income in the second period without consuming anything in the first period, you consume $110,000 in the second period. That is your savings of 100,000 plus the interest of it. Okay. Now, if you look at this, this is the optimum point because the budget line is tangential to the indifference scale at this point. At this point, the individual is consuming 50,000 in his youthful age. In period 1, he's consuming 50,000, which means that how much is he saving? Okay, he's consuming 50,000, and so how much is he going to save? So if you guessed 50,000 savings, that is correct because he's consuming 100,000. So he's earning 100,000. So if he's consuming 50,000, then remember savings is income minus consumption. So he saved 50,000. So when you get to the old age, that's period 2, he will consume the 50,000 that he saved and then the 10% interest of that 50,000, which will be 5,000. That is why he's consuming 55,000 in the second period or the old age. Okay, so you consume 50,000 now, you consume 55,000 in the old age. So this is the optimal bundle. Okay, 55,000 for old age, 50,000 for current period. Now, what happens? Okay, we want to look at the effect of a change in interest rate. What happens if there's an increase in interest rate? What is going to be the income effect? What is going to be the substitution effect on current and then future consumption? What about savings? Remember, we said interest rate is the cost of current consumption. So if there's an increase in interest rate, then it means that there's an increase in the price of current consumption. So let's decompose this into substitution and income effect. Substitution effect is that we have two consumption. You can either consume now or consume later. Okay, and we are saying that current consumption, the price of current consumption is the interest rate. So if there's an increase in interest rate, it means that now current consumption has become more expensive relative to future consumption. So whenever there's an increase in interest rate, the substitution effect will cause current consumption to fall. Because if you save more, you earn more interest. So why do you want to consume now? So as current consumption is falling, it means that savings will rise. And because of increase in saving, remember whatever you are saving now, you consume it in the second period. So as current consumption is falling, future consumption will rise. That is a substitution effect. Now let's look at the income effect. For income effect, interest rate is increasing and you are a saver, you are saving. When you save, you earn interest on it, which means that there's going to be an increase in your lifetime income. Okay, there's going to be an increase in your lifetime income. Now, because of the increase in savings, now you can consume more in both periods. Okay, because now there's going to be an increase in your lifetime income. So because of that, what do? You have to consume more now. There's an increase in interest rate. Level third year, as I was saying, you get to understand this better. It doesn't matter where the increase in income comes from, whether increase in income is going to happen in the second period or the first period. You can still consume more in both periods. So because of the increase in interest rate, when you save, there's going to be you get more money in the second period. So there's an increase in your lifetime income. So you can consume more in both periods. So you consuming more now means that you consume less in the future. So you save less now. Okay, so the income effect is causing the individual to consume more now, but the substitution effect is causing the individual to consume less. Okay, it's causing the individual to consume less. So what is going to be the total effect? You see that it's going to be ambiguous. It will depend whether substitution effect is more than income effect or not. You see, substitution effect is causing us to consume less. Okay, but then we are just dealing with current consumption. If you take future consumption, the substitution effect is causing future consumption to increase. Income effect is also causing future consumption to increase. So we know that whenever interest rate increases and you are a saver, definitely your future consumption will increase. But the current consumption is what is ambiguous. The substitution effect is causing current consumption to fall. The income effect is causing it to rise. So what is the total effect? So now this is the diagrammatical representation. This was the initial budget line and the optimal bundle. Okay. Now when interest rate increases, the budget line will rotate outwards. So this is the point here. Now, if you look at this, if you check current consumption, you see that there's a reduction in current consumption. This means the substitution effect is more than the income effect. It's a substitution effect to cause the individual to consume less, and then the income effect will cause him to consume more in the first period. So if the total effect is a reduction in current consumption, then it means that the substitution effect was more than the income effect. So if you are consuming less in the current period, then it means that there's an increase in savings. Okay, it means there's an increase in savings. So that is what happens to current consumption when. What if the income effect is rather more than the substitution effect? This was the initial optimum bundle. After the increase in interest rate, budget line rotates outwards. This is the new bundle. So with this being the new bundle, if you look at this, you see that there's an increase in current consumption. So this is the case where income effect is more than substitution effect. So if you are consuming more in the current period, it means that you are saving less. So your savings will fall. Okay, your savings will fall. All right, so these are the applications. Okay, these are just giving a summary of what we have done. Okay, a summary of what we have done. So this is where we end for the consumer theory and its applications. See you next time.